4 deals with lines. Everything about lines, slopes, everything. We're going to review everything. So when we talk about lines, we really talk about linear functions. And lines can have these forms. They look like this, or like this. Obviously, this one is a horizontal line. And what we know about it is the slope is 0. M is the slope. Then this one is also an important line. It's a vertical line. And this one doesn't have a slope. It does not. We write undefined. This line that goes from left to right, if you want from negative infinity to infinity, which is increasing from left to right, we discussed increasing, decreasing last time, has a positive slope. This one that decreases from left to right has a negative slope. Also, we have two different situations in which two lines can be parallel or they can be perpendicular. So the slope of this line is M1, the slope of this line is M2. If they are parallel, they must have the same slope. It's mandatory. Now, here these two lines are perpendicular, meaning they are forming 4 90-degree angles. So I'm going to say that this line has slope M1, let's say this one has slope M2. The relationship is not this. The relationship is very different. I prefer to say, because it's easier for me and shorter, but you may say, no, I want to stick with what I learned a long time ago, which is absolutely fine, and it's the same thing. I prefer saying the product equals -1, which is the same with what you learned a long time ago that says M1 equals -1 over M2. If you cross multiply, you get that. Same thing. For me, it's more difficult to say this. The slope of one line is the negative reciprocal of the slope of the other line. Instead of M1 times M2 equals -1, which is exactly the same. Remember it the way you like, and these are perpendicular lines. Parallel lines. Okay? Now, we do have the definition of the slope and 2 more equations, and that's all, really. So we have y equals mx plus b, and we have y minus y1 equals the slope times x minus x1. What do they mean and when they are used? This one is slope intercept. This is the y-intercept in the form of 0, b. Slope intercept form. Everyone remembers, even if you don't, it's okay. There is no shame. We'll go over everything. So this is the slope, and this is the y-intercept. The y-intercept must have 0 for x. I will review that with you in a minute as well. This is the y-intercept, 0, a number. What about this? Here, this is the slope, and this is a point. The point x1, y1, normally not 0, a number. Because if I have 0, a number, I will immediately present this equation. If I don't have 0, a number, I will use this equation, which is called point slope form. One last thing before we look at problems. If we are given 2 points, let's say x1, y1, and x2, y2, 2 points, then the slope is rise over run, which means y2 minus y1 over x2 minus x1. So that's how we determine the slope of a line passing through 2 points. Okay? Alex, are you there? We can see you. Okay. So let's work on all sorts of problems. Please open on page 267 and later on page 279, and let's choose whatever we need to, you would like to work on to practice what we just discussed. I think we should start with an example with finding the slope from 1 through 10. If you want to choose, that's fine. If not, I will. Okay, I'm going to choose 7. And this is on page 267. We're given 2 points, -2, 4, and -1, -1. They're asking us to identify, find the line, find the slope, the whole thing. I'm adding on to the question. So first of all, I will label them as x1, y1, and x2, y2, or at least you imagine that you label them. And we find the slope as -1. Be very careful how you write it. -1 minus 4 over -1, but the opposite of -2, that must change into +2. The numerator becomes -5, the denominator becomes 1, so that's a nice slope of -5. None of the points is 0, a number. I will not use this. I will use this equation. And use any point. I prefer this one. I like it better as -1, -1. I write the equation as y minus y1 equals the slope times x minus x1. And again, you don't have to use my method, but this is what I like to do. I will replace the slope by -5. I will replace x1 by -1 and y1 by -1, writing them underneath, because otherwise I have to use nested parentheses, and I'd rather avoid that. Okay, so y minus -1 becomes y plus 1. This is -5, and x minus -1 will be x plus 1. Yes, I will distribute and move 1. So I have -5x, -5, and I move 1 to the other side, and that's my y. Finally, y equals -5x minus 6. So what does this represent? It represents the equation of the line passing through the given points. Any questions, please? Any questions on, do you remember this? You don't remember? You need more examples? Please say something so I know what to do, because I'm not sure what to do. Should I move on to graphing?
More examples.
Say it again.
More examples.
Okay, please choose. You can choose any 2 ordered pairs.
Could you not move the paper too far to the right? I don't know. There's like a glare, and I couldn't see some of the right.
So you need this back?
No. Just.
It's one of the lights is making one side of the paper shine really brightly.
I'm not sure what to do.
I don't know. Just don't move it too far to the right.
Is this better?
Yeah.
I guess.
I can try to put a paper here in front of the lamp. Is this better?
Yeah.
Okay, perfect then. Good. So can anyone give us any 2 ordered pairs?
Let's do number
Number 8 is good. Where is it? Okay, so we have 6 minus 4 and 4 comma negative 2. So the same procedure, I find the slope, y2 minus y1, negative 2 but plus 4 over 4 minus 6, always in the same order. The numerator is 2, the denominator is negative 2, so the slope is negative 1. I use y minus y1 equals the slope times x minus x1 because none of the points is 0 comma a number. I do not have that. I'm going to use the first point as 6 and negative 4 and the slope of negative 1. So negative 4 will be y plus 4. This is negative 1 and then x minus 6. I distribute and bring over 4. So negative x but plus 6 and minus 4. So this is final as negative x plus 2. And that is the equation of the line passing to the given points. Let's look at some graphing now. So let's graph. And I'm going to choose a few. Number 1, which is for 57, as 3x minus 18 equals 0. Then I would like to use, to look at f of x equals 3. And the third problem, let's say, is 6x minus 5y minus 20 equals 0. So let's take it step by step. Here I do not see y, so I'm going to have to solve for x. When I move 18, I get 3x equals 18. I'm adding 18 to both sides, and then I have to divide by 3. So I have an equation that gives only x. What type of equation will this be? What type of graph? What type of line will this be?
Is that, vertical line?
Very good. Awesome. Thank you. It is a vertical line at 6. 1, 2, 3, 4, 5, 6. And I have to label it. Indeed. It shows position. Is this a function or a relation?
A relation.
Excellent. By the vertical line test, it's not a function. Great job. Thank you. Here, I don't have anything to do. I just have to identify that this is y equals 3 and ask myself what type of line is that? How do I graph it? And the answer would be, since it's not position, it's altitude, what type of line can it be?
Horizontal.
Very good. Awesome. Thank you very much. It is y equals 3. Y equals 3, horizontal line. Slope 0, slope undefined. Okay, for this one though, I will have to find the x and y intercepts. So let's talk a little bit about that before we address question 3, line 3. Okay, so these are the x and y axes. This is the origin of coordinate system, also called Cartesian system. This is the x-axis, which now we know has altitude 0. So this is y equals 0. This is the y-axis, which gives position. And it's at 0. Right here. It's not here. It's not x equals 6. It's not x equals negative 3. It's right here at 0. So this must have the equation x equals 0. In order to find the x and y intercepts for any graph like this one, I have to determine a point here and a point here. Somewhere. I don't know where. But what I do know is that all these points will have some y, but x 0. All these points, for example this one, will have some x, but definitely y 0. So, keeping that in mind, when I plug in 0, I determine the y-axis, 0 for x. I determine the y-intercept, not the y-axis, sorry. I determine the y-intercept. When I plug in 0 for y, I determine the x-intercept. And that's what we are going to do there. Please do not solve for y. That's a total waste of time. So I'm going to replace x by 0. I just cover it. So the equation becomes negative 5y equals 20. Negative 5y equals 20, so y is negative 4. Right here, right now, I write the ordered pair. I plugged in 0 for x, and I got y to be negative 4. Second option, I plug in 0 for y. So then I have 6y equals 20. 6x equals 20. So then x equals 10 over 3. So I found the ordered pair. 10 over 3, 0. That's all I needed. Waste of time to solve for y. There is no need. We need the x and y intercepts. Okay, so then now, 0 for x, negative 4 for y. 1, 2, 3, 4. 10/3 for x is a little bit more than 3. 1, 2, 3, 4 here. 10/3 for x, 0 for y. These are the 2 points. I connect them and extend the line. I have to write the name on the line to the side, to the left, down. It doesn't matter where, but you have to write somewhere this, so we know what we graphed. I'd like us to look at some, oh, what I forgot, piecewise defined function. I don't want to forget that. So let's create a piecewise defined function. My apologies. Oh, I know why, because I put my paper up here for the shade. Okay, so I don't want to forget. So can anyone give us a piecewise defined function to graph? I wanted to show that, and then we'll go back and look at word problems with lines and linear models.